Okay, so let's go ahead and take a look at the answers to the questions in your packet. So the first example was regarding Kate and Carl, and basically they had the production of t-shirts and birdhouses. And so Kate was able to produce 6 t-shirts and or 2 birdhouses with their productive capacity, with her productive capacity. For Carl, it was a 1-for-1. So this is pretty easy to analyze in that respect. And this is a OGO question, or other goes over, because you have a total amount of t-shirts or a total amount of birdhouses. So we're going to use the other goes over method and basically do a little division to determine the per unit opportunity cost. Okay, so when we do the other goes over method, we end up with 2/6, which breaks down to 1/3. And remember, the trick to it is that whatever is in the top of the table, for instance, here is t-shirts, the cost is going to be represented in the row. So for 1 t-shirt, it is going to cost them 1/3 of a birdhouse. All right, next we're going to go to the cost of birdhouses. So per unit opportunity cost, 1 birdhouse will cost Kate, based on the numbers, 3 shirts. So clearly that is very costly relative to her production of t-shirts. Again, for Carl, it's a 1-for-1 or proportional opportunity cost. So that's kind of easy. And you can see that reflected there. Okay, now let's go through it. So it costs Kate for 1 shirt, it costs Kate 1/3 of a birdhouse. It costs her 3 shirts to produce a birdhouse. And for Carl, again, it's a 1-for-1. So now let's look at who has the comparative advantage. When we're looking at these two numbers, again, whatever is up here, the opposite is in the table. We're looking for who can do the respective productive ability at a lower cost. So I'm looking for these things in terms of lower opportunity cost in the production of one versus the other. So for Kate, it only costs her 1/3 of a birdhouse, whereas for Carl, it costs 1 full birdhouse. And for over here on birdhouse side, you can see that Carl can produce birdhouses at a lower capacity or lower cost in terms of t-shirts. Now again, you can change these into dollar signs if you want, and that might help. Look at it like saying, okay, 1 birdhouse costs him $1, whereas Kate, it costs $3 to produce. Well, it doesn't make sense for Kate to produce it if it's that much more expensive. And over here, you could say, well, it costs Kate 33 cents to produce a t-shirt, and whereas it costs Carl $1 full dollar. So who has the comparative advantage when producing t-shirts? Well, we can see it here, Kate. Who has the comparative advantage in producing birdhouses? Well, we can see that, it's Carl. Therefore, Kate should produce the t-shirts, Carl should produce the birdhouses, and then they should trade. Okay, next question was on India and the United Kingdom, also a output question. So total amount of rice and beans in the table. So we're going to go other goes over, and pretty simply put, 10 over 20, 20 over 10, 15 over 5, 5 over 15. So when we analyze this, we're going to break it down into the opportunity cost for each one of these things. So 1 rice, right, is going to cost 1/2 of a bean. Okay, 1 bean will cost 2 rice for India. For the United Kingdom, 1 rice costs them 3 beans, and then 1 bean costs them 1/3 of a rice. Now, like I said, the trick we can use here is to look at these as dollars. So it costs, let's say, India 50 cents to produce a rice, and it costs the United Kingdom 3 full dollars. Or over here, 1 bean costs $2 for India and 33 cents for the United Kingdom. So if that helps, that's something you can do. But now we're looking for who can do what with less, okay? So who has a comparative advantage in producing beans? Well, we look at it here, we go, all right, this person or the United Kingdom can do it less expensive, like 33 cents versus $2. Who has the comparative advantage when producing rice? Well, we can, again, look here and say, okay, this costs them 50 cents versus $3. So India should focus on rice production. The United Kingdom should focus on the beans. All right, this question is an interesting one because what happens with this is when you work out the comparative advantage, the other goes over, they end up having the same opportunity cost, which is kind of interesting, right? So you'd say, okay, for Russia, it costs them 1/3 of the butter, but it costs Cuba 1/3 of the butter as well. to produce a gun. To produce a butter across both countries, 3 guns. And so the moral of the story here is these 2 countries are sharing the exact same opportunity cost. Therefore, it doesn't really make sense for them to trade. There's no comparative advantage to be had. So when we analyze the numbers, again, we see that the opportunity costs are the same. Therefore, these 2 countries don't need to trade. Now, I've taught that for many years and kind of just looked at it like, hey, you probably won't see that on the AP exam. But a couple years back, that type of question actually popped up. So we should know that, right? If they have the same opportunity cost, there's no comparative advantage, no reason to trade. Okay, here we have Italy and Morocco. Now notice on this one, there are hours represented in the table. And so we have to look at this differently, right? This is an input question because whether it's hours or workers or land, those are all resources. And if in the table the resources are reflected, then that's an input question. So we're gonna go other goes under, which means I'm gonna take the 2 and put it under the 4, right? I'll take the 5, put it under the 1, and vice versa. Just a little bit different, but similar idea. We're still looking for ratios. Okay, now this first question says, which country has the absolute advantage? Well, in car production, Italy is faster than Morocco, right? Even though that number is lower, it's lower because it represents hours. And so, you know, this person or this country can do it faster than Morocco. Now, Morocco has an absolute advantage in bike production because they can do that faster. Okay, but now let's work out the numbers. So we're taking the 4 over the 2 here, 2 over the 4, 5 over 1, and then 1 over 5. And those are the costs per unit of each one of these items. So 1 car costs Italy 2 bikes, 1 bike costs Italy half a car. 1 car costs Morocco 5 bikes, whereas 1 bike costs 0.2 or 1/5 of a car. Okay, so who has the comparative advantage in car production? Italy, because they can do it cheaper. It only costs them 2 bikes or $2 to produce a car. Over here, it only costs Morocco basically 20 cents, okay, versus this 50-cent mark that Italy is engaging in. So we have our comparative advantages there. Therefore, Italy should produce the cars, while Morocco should produce the bikes, okay? And so we have that comparative advantage there in the analysis, therefore. Okay, the next video we're going to talk about, or what we're going to talk about, is and represents the terms of trade and the gains from trade. So we'll take a look at that now. Let's go to your packet and look through those questions. Okay, so for this part of the class, we're going to look at are the terms of trade and the gains made from trade. So this is kind of the third part of all of this stuff. The first is, just understanding the idea of specialization, then figure out the comparative advantages, figure out who should do what, and then finally figure out what the terms of trade should be, and then how they gain from trade. So here we have the young man and the old man depicted again on this slide. And what you can see is what each of these individuals are capable of when they specialize and how much it costs them when they decide to produce one thing versus another. So for instance, the young man, when he specializes in coconut production, every time he collects 3 coconuts, it costs him 1 fish. So it's kind of like saying costing $1 for 3 coconuts. And over here, the old man, every time he goes out and catches a fish, it costs him 2 coconuts or $2. So if they choose to do what they're good at, there's a cost, right? And so, but what can they do on their own? Well, the young man can focus on coconut production, but it costs him a fish. And the old man can focus on catching a fish, but it costs him some coconuts or 2 coconuts. So the overarching question would be, would it make sense for the young man to take all of his coconuts, since he's producing those, and trade them to the old man for 1 fish, right? Does that make sense? And you're probably thinking about this and go, okay, if he gives the 3 coconuts up, then how many fish should he be getting, or would it make sense for him to do that? So the thing is that he's not going to trade 3 coconuts for 1 fish, right? In other words, why would he do that? Well, because realistically, he could do that on his own side of the island, right? So he could say, well, if I'm going to give up 3 coconuts, I'll just go catch my own fish. So for him to gain in this situation, he has to get a fish for cheaper than the 3 coconuts that he can do on his own. In other words, he wants this transaction to be cheaper for him. So he wants it to be less than 3 coconuts when he gets that fish, right? Because again, on his side of the island, he can just do this on his own. He can go catch a fish. It's going to cost him 3 coconuts or $3, and he can do that on his own. If he's going to trade, he wants it to make sense, okay? So would it make sense for him to trade all of his coconuts to the old man? No, it wouldn't make sense to do that, right? And so over here, if we look at the old man, you know, when he catches a fish, he gives up 2 coconuts, right? So if he's going to trade this fish to the young man, he's going to want more than those 2 coconuts that he sacrifices when he does this on his side of the island. So in other words, like he's going to go, all right, look, I'm going to trade you this fish. I'm giving up 2 coconuts on my own, right? So if I do this on my own, I get the fish and I can give up 2 coconuts. But if I'm going to give this fish up to you, young man, I need to get more than I could have done on my own. So again, on his own, he could catch the fish or go get those 2 coconuts. He's not going to give up the fish for 2 coconuts because he can do that on his own. He's not going to trade that to the young man. So what does he have to get in order for this to make sense? He has to get more than 2 coconuts, right, to make profit. So he's going to trade this fish, this one fish, and he wants more than the 2 coconuts he could do on his side of the island. So he's going to trade the fish. He's going to get more than 2 coconuts. So what should this transaction look like? Well, for the young man, he's going to give up less than 3, right? And the old man wants to get more than 2. So we can kind of meet in the middle here and say, look, if you give up this fish, old man, I'll give you 2.5 coconuts. And so how will that make them better off? Well, the old man, instead of having 2 coconuts that he gets, now he has 2.5. And the young man gets both the fish and retains a half of a coconut. So like the transaction will look something like this. There goes the fish. Okay, so he's got his fish, and he's trading the old man 2.5 coconuts, right? So now the old man has more coconuts than he would have had on his own, and the young man has a fish and a half of a coconut. So there's profit involved there as well. Okay, so these are called the terms of trade, and that's kind of a little theoretical look at it. But let's look at how to solve these problems and some of the different analysis of it. All right, first of all, the terms of trade are when you have an exchange where both parties are going to benefit, okay? So we're going to find out where they should trade or what they should trade for. What are the terms of this negotiation? Gains from trade is how they profit. So, you know, that extra half of a coconut for both of these parties and retaining the fish or giving up the fish for an extra half of a coconut. So they benefit through what are called the gains of trade. All right, now, how do we solve this problem? There's a couple different ways where you can determine the terms of trade, but I found this little trick to work pretty well. And what I do is I set up what is called a per unit opportunity cost PPF. And then what I do is I analyze what each of these parties are capable of doing and what they should do based on the analysis of the data. Okay, so the way it works is you set up a per unit opportunity cost PPF. So per unit in this case is going to be 1 fish for a certain amount of coconuts, okay? 1 fish for a certain amount of coconuts. Now, where do I get this information? I just look up here to my table, and actually I'm going to look at this side of the table because that's what I'm analyzing, fish to coconuts. And I'm going to say 1 fish for a certain amount of coconuts, right? And these are the production capacities for each of these people. So how many can the old man produce? Well, he can produce 1 fish or 2 coconuts. So that's our old man's PPF, right? Again, think back to the production possibility model. What does it represent? Well, it represents the capacity to produce. So you've got, in this case, 1 fish or 2 coconuts, right? It's a sliding scale. It's almost like the links and smiles. You know, do a certain amount of links, a certain amount of smiles. And it's a sliding scale in between. But in this case, we're just going a 1-4. 1 fish or 2 coconuts. Now, what can the young man do? Well, the young man can do 1 fish or 3 coconuts, right? And so we said that basically, and this is our young man's PPF, we said that basically the old man should be focusing on fish production, right? Because it's cheaper for him, okay? And the old man, or the young man, sorry, is going to be producing the coconuts. So think about it like this. Here's the old man. He's maxing out on fish production. And here's the young man. He's maxing out on coconut production. And then they're going to trade, right? And so the trick to this thing is it's got to be cheaper for the person making whatever product is on the X, and it's got to be more profitable for whatever person is producing on the Y. So basically, for this old man to give up this 1 unit of fish, he has to get more than 2 units of coconuts, right? Profit. And for the young man, he's giving up coconuts, right? He doesn't want to give up 3 for 1 because he can just do that on his own side of the island. So it has to be cheaper for him. It has to be less expensive than 3 so he can still retain some profit and get that fish. We just showed that a slide ago. So basically, it has to fall in between these 2 points of opportunity cost. So in this case, it's going to be 1 fish, like we said last slide, for 2.5 coconuts. But what we're doing here is we're looking at the terms of trade on a production possibility graph, which is really just what we call per unit opportunity graph, okay? All right, now what we're going to do is we're going to graph this out, okay, and show how they gain from trade. Okay, and so now what we're going to do is we're going to look at what happens if the old man takes what he's good at, specialized on fish, and maxes out, right? He's going to catch as many fish as he can, and he's capable of producing 10, which we saw over here. So he's going to catch 10 fish, but he wants some coconuts, right? So he wants to trade some. So he's going to take those fish and he's going to trade 8 of them, okay? Now, where did that number come from? It's just an arbitrary number. Okay, so now what we're going to look at is what happens when the old man self-sustains and does this activity on his own. So let's just say that he is maxing out on fish production, right? Because that's what he's good at. So we can see it over here that he can, tap out at 10 fish, okay? And that's what he's capable of doing. So he's producing many fish as he can, but sometimes he gets bored of fish and he's like, well, I want to trade some fish for coconuts. And again, we're looking at self-sustained. So trade is probably the wrong word. He's going to give up some fish for coconuts, right? On his own, self-sustaining. So he goes, all right, I'm going to give up 8 of these fish, just an arbitrary number we selected. And what I want to know is what is he capable of producing when he does that? Okay, so he's giving up 8. How many can he produce in terms of coconuts on his own? Well, at 10, he can produce none. But I can see at this production point what he is capable of producing, okay? He is able to produce 16 coconuts. So it's like I went from 10 and 0 to now 2 and 16. All right, that's just our little production possibility sliding scale there. So before trade, he's capable of producing 2 fish and 16 coconuts. But now what we're going to do is we're going to determine what he is capable of doing when he trades. Okay, so now we're still taking these 10 fish that the old man is maxing out on, and he's going to trade, right? He's going to trade 8 of them, okay? But what is he going to get in return? It's not going to be 16 because the terms of trade, which we analyzed in the last slide, are 1 fish for 2.5 coconuts, right? So he's got 8 of these things that he's trading, and that's going to multiply by 2.5. For every fish, he gets 2.5 coconuts, and then that's going to amount to more than 16. In fact, it's going to amount to 20, okay? So 8 times 2.5 is 20, and so now he ends up with the same amount of fish, but he's got 20 coconuts instead of 16. Now, how did that happen? Again, he's trading, right? He's taking every 1 fish and getting 2.5 coconuts. We determined that on a previous slide. So now he's doing this 8 times, right? So he's going 8 times 2.5 equals 20. And he gains, in this case, more than he could on his own. And in fact, it actually pushed him out of his PPF. So this idea of trade is actually akin to a technological advance. Okay, so how many did he gain from trade? In this case, he gained 4 coconuts, right? Because he gave, for every 1 fish, 2.5 coconuts, multiplied 8 times, he gets 20 coconuts with his 2 fish. Or, he's able to retain those 2 fish. So he traded 8 for 20, basically. And that ends up being a gain of 4. So that's pretty cool. Okay, so let's go ahead and look at this example. We're going to walk all through the steps so that you have an idea how it works from top to bottom, okay? And so in this example, we have Slavia and Libos, and they are considering the trade of 2 goods. That's clothing and food. Slavia can produce 10 food or 10 clothing. Pretty easy. Libos can produce 3 food or 9 clothing. Okay, so we've inputted our information here. The next step I would say is to determine, is this an output or an input? Well, what's in the table, right? What's in the table? Food and clothing. So this is an output question, and we're going to treat it as such. Okay, So the next thing we need to do is we need to go through and work this out to determine the opportunity cost per unit opportunity cost. So I'm just going to simply put my 10 over my 10, and again, 10 over 10, then 9 over 3, 3 over 9. And what I've done here is I've already broken this down and reduced it down to its most common form. So what we're saying when we look at this table here is how much does it cost in terms of clothing every time each one of these countries produces one food, and how many food does it cost every time they produce one clothing. Okay, so we've got that analysis, and we can see now what it costs each one of these countries. So for Slavia, it costs them one clothing, every time they produce a food, and then one food every time they produce a clothing. So it's a 1-for-1, that constant opportunity cost. For Libos, it costs them 3 clothing every time they produce one food, or 1/3 of a food every time they produce a clothing. So we can kind of see already who's better at what comparatively. But let's just walk through it. All right, over here for Slavia, it only costs them 1 clothing or $1 to produce a food, right? So like they should definitely be doing that. And over here, it only costs Libos 33 cents to produce clothing versus Slavia's $1. So they should definitely focus on that, right? 1/3 of the food versus 1, cheaper. So the comparative advantage in food production is definitely Slavia, okay? And the comparative advantage in clothing production is Libos. So we've got that settled, we've got that handled, right? Other goes over, break it down, determine who has comparative advantage. Now we're going to go up here and we're trying to figure out the terms of trade, okay? So remember, we're going to use this per unit opportunity cost method. And for me, I always like to take it where the numbers are a little cleaner. Like you could do either side, but I like to do it where it's a little cleaner if they're going to give me an option. And so on this one, we have one food, right? And so we're going to bullet point that. And then we have to look at what the opportunity cost is in terms of clothing. Well, we can see the opportunity cost right here in this table, right? So we go, okay, it's a 1-for-1, that's Slavia. And for Libos, it's a 1-for-3, okay? Now remember the trick. For this to be beneficial, Slavia has to get more than 1, and Libos, who's producing the clothing, you can see at this table, has to give up less than 3, okay? So it can be anywhere in between there, but obviously a nice clean number is 2. So you could say 1 for 1.25 or 1 for 2.75 or anywhere in between, but 2 is clean. So if Slavia wants to experience gains from trade, then they must agree to trade 1 food for 1 clothing. Sorry, more than 1 clothing. And if Libos wants to experience gains from trade, they must agree to trade for less than 3 clothing. And to get that food, right, they want to give up less than. So Slavia wants to profit by getting more than 1 clothing, and Libos wants it to be cheaper by giving up less than 3, okay? And that's the trick. Again, it has to fall in between those two. So when you're setting this up, you're doing your free responses or your practice problems, that's a good method. Create that little per unit opportunity cost. It's definitely helpful. Okay, now we're going to take a look at Slavia and see what the gains from trade would be if this country decided to trade. So let's start off with what they can do, okay? So they're going to either produce food or clothing. It's a 1-for-1, nice proportional opportunity cost there. And we're going to say that Slavia focuses on food production because that's what they're good at, right? But they're going to, they want to trade some food, okay? So let's see what would happen if they did this domestically or if they did this on their own, self-sustaining. So let's say they gave up 1 in their own country, right? Like this is no trade, just self-sustaining. If they did that, then basically what happened is they would be able to produce 1 clothing. So that 1 food, that sacrifice of 1 food would give them that 1 clothing, right? And that's what that bullet point right there represents. Again, it's a 1-for-1. But what happens if they trade? Well, a moment ago, we said that the trade should fall in between the opportunity cost, right? It should fall in between these 2 numbers. And that's going to make sense for both parties. Like it's going to be profit for Slavia and cheaper for Libos to trade, right? To get that 1 food. So now when they give up the 1 food, they're actually getting 2 clothing. Okay, so it's like pushing them to this number, and it's getting them outside the PPF, right? And so this is a good thing for them because they're not only giving up that 1 food that they were going to give up on their own country, on their own domestic production, but now they're getting more through trade than they would have. Okay, so they benefit in the sense that they get 2 instead of 1, right? That's good. And so this answers the question: why do we trade? The answer is we get gains, right? We get gains from trade. And so in this case, the gains from trade are one, clothing for slot week, okay? So they give up one, they get two instead of one. So taking it from top to bottom is a good way to analyze it, like from the very beginning of the problem set all the way through, figure out comparative advantage, figure out the terms of trade, figure out the gains from trade, right? It's like 3 steps, okay? Okay, so what I would like you guys to do now, let's go ahead and pause here. And what I'd like you to do now is to do some problem sets from your packet. And so we'll take a look at that. That's going to be on page, starting on page 8 and going all the way through to page, looks like page 12, okay? So get as much of that done as you can. There's a couple of free responses in there, and we'll have an opportunity to go through that in class when I get back, all right? So have a good day, hope that helped, and we'll see you in class.